So this video is an introduction to naming organic compounds. In this video we're going to be covering naming the alkanes, which are hydrocarbons with only carbon-carbon single bonds. We're not going to be dealing with the functional groups just yet, but mostly we're going to be dealing with naming organic compounds with branches, and we're talking straight chain alkanes. So the first step is you need to memorize the names of the straight chain alkanes. There's no way around it. These are just names that you have to learn. So for example, you need to know that a 3-carbon chain is called a propane, or for example, a 6-carbon chain is called a hexane. If you need to, you could pause the video and take a screenshot here. You're also going to need to memorize the names of the common branches, the methyl, the ethyl, the propyl, and the butyl group, and know what they look like when they're coming off of a larger molecule. In addition to the common branches, there's some branches that have branches within them, and we typically refer to them by their common name. So for example, a propyl group, when the point of attachment is on the center carbon instead of the end carbon, is referred to as an isopropyl group. A butyl group, when the point of attachment is on the second carbon in as opposed to the end carbon, it's referred to as an isobutyl group. A secondary butyl group, also called a sec-butyl group, is when you have a branch off of that butyl group. And a tertiary butyl group is when your butyl group is branched completely. So you want to be able to recognize these in both the condensed and skeleton structure form. Also, you need to be familiar with how the halogens look when they're coming off of a hydrocarbon. You need to be familiar with bromo, chloro, fluoro, and iodo. All right, let's get started with the naming. So the naming has 4 components. There's the prefix, parent, locant, and suffix. The prefix is going to tell you the location and identity of the substituents. And by substituents in this video I'm really referring to branches, but we'll see later on that substituents can also mean a functional group as well. The parent is your longest continuous carbon chain, and I'll show you how to identify that. The locant is the location of the primary functional group. That's going to become more relevant later on when we cover each of the functional groups one by one, but I'm not going to cover that on this video. The suffix is essentially the ending, and the ending tells you what's the primary functional group. So in this video, it's going to be an A-N-E ending, which is an alkane, and everything we're going to be covering in this video is going to be an alkane, a straight chain hydrocarbon. Okay, so the first step is to find your parent molecule. Find the longest continuous carbon chain in your molecule. So for example, on the left-hand side, you have a molecule which is 6 carbons long. Remember, carbon lives on the ends and the bends. So if you count them up, you'll see you have 6 carbons. And if you forgot what a 6-carbon chain is called, you go back to that second slide and you see that it's called a hexane. The molecule on the right, if you count up the longest continuous carbon chain, you'll see there's 4 carbons in that chain. If you go back to the table on the second slide, you'll see that a 4-carbon chain is referred to as a butane. Sometimes you're going to encounter numerous ways to number a parent compound. You're going to always want to choose the parent with the greater number of branches if more than one is possible. So for example, if you look at the molecule on the left, the longest continuous parent chain is a hexane. Now you can draw it this way with a methyl and an ethyl group coming off, and that's the correct way to do it. But if you imagine that this all has free rotation, you could flip these two, and you could also draw it as a hexane with an isopropyl group coming off. 1, 2, 3, 4, 5, 6. So what this rule is saying is that you would name it as a hexane with a methyl and an ethyl, not as a hexane with a single isopropyl group. Second step is to number the atoms on the parent chain. Begin numbering at the end closer to the first branch. So for example, in this molecule, you see there's a methyl group coming off closer to the left side, so we're going to begin numbering closer to the left side. If there are branches equidistant from both ends, you're going to begin numbering at the end with a second branch point closest to it. So in this example, you have a methyl coming off 1 carbon in from both ends, here and here. So now we're going to let this second branch point determine which end we begin numbering at. So this next branch point is closer to the right side, so we're going to begin numbering at the right-hand side. Now I'm going to take this example and we're going to take it to completion and name it in the next slide. The second step is to identify and number the substituents coming off of the parent molecule. So in this molecule, we have a methyl coming off at position 2, and another methyl coming off at position 5, and then we have a bromo coming off at position 3. Next step, write the name as a single word. So this molecule gets named as a 3-bromo-2,5-dimethylhexane. When we write the name, the substituents are listed alphabetically. So in other words, bromo, or B, comes before methyl, or M, in the alphabet, so we list the bromo group first. If you have two of the same substituents, as in this example, you say it's a di, like a dimethyl. If, for example, we had 3 methyls on the molecule, we would call it a trimethyl. If we had 4 methyls on the molecule, we would call it a tetramethyl. When you have these prefixes, di, tri, and tetra, do not use them to alphabetize your name. So let's go through a few examples. Typical question, name the following compound. So what you want to do is, step 1, find your parent molecule. Well, if you count up your longest continuous chain, you'll see that it's 7 carbons long, therefore is a heptane. 7 carbons long. You might also just want to double check that you can't draw it another way. But this becomes 6 carbons if you go this way. Next step, begin numbering at the end closer to a branch point. Well, if you eyeball this molecule, the branches begin closer to the left side, so we're going to begin numbering at the left side. Third step, identify and number the substituents. Well, there's a chloro group at position 3 and an isopropyl group at position 4. Then name it as a single word. It gets named as a 3-chloro, 4-isopropyl heptane. Here's another kind of question you need to be able to answer, which is where you're asked to draw a compound and you're given the name. So in this example, you're given the name 4-ethyl-2,2-dimethyl-octane. First step, you want to identify the parent. That's going to be your octane. Write out a hydrocarbon skeleton with 8 carbons. So you could draw it, if you're going to do the line bond structure, you could write it this way. Otherwise, you could just draw a zigzag or your skeleton of 8 carbons. Next step, you want to number the carbons and place the substituents. So we number the carbons, and now we're going to place the substituents in their location. So we have an ethyl at position 4, according to the name, and we have 2 methyls at position 2. Had you chosen to draw this as a line bond structure, you would then need to go and fill in all the hydrogens at this point. But the skeleton structures are nice because after this you're done. So let's go through a few examples that might give you a few scenarios that are kind of subtle rules that may not be listed in the main rules in your textbook. So we're going to name the following compounds. They're very similar, but just so you know how to navigate this. So let's start with the first one. The first one is a parent. The parent is a pentane. It's 5 carbons long. We're going to begin numbering on the left side because the branches are closer to the left side. We have a methyl at position 2 and another methyl at position 3. So this guy gets named as a 2,2-dimethylpentane. Let's look at the molecule below. The molecule below is also a pentane. It's 5 carbons long. We're going to begin numbering at the left side because the branches are closer to the left side, or the first branch is closer to the left side. We're going to identify and number the substituents. Well, we've got a methyl at position 2, and then we have 2 methyls at position 3. So this guy gets named as a 2,3,3-trimethylpentane. We want to list position 3 twice because there's 2 methyls at that position. Let's look at another scenario. We're going to name these compounds. They are similar, but they're going to test another little subtle rule. Starting with the compound on the left side, we have an ethyl and a bromo group coming off of a heptane. So our parent is a heptane. If we look at it, if we eyeball it, we'll see the branching is closer to the right side, so we're going to begin numbering at the right-hand side. So the ethyl's at position 3 and the bromo's at position 4. So this guy gets named as a 4-bromo, 3-ethyl heptane. We list the bromo first because B comes before E in the alphabet. Let's look at the example on the right-hand side. Well, okay, so we have a branch coming out at the third carbon on the left side and also the third carbon on the right side. Now, if these substituents were identical, it wouldn't matter which side we begin numbering on, but they're not identical. So when they're not identical, but they're equidistant from both ends and there's not a second branch to help you decide, what you're going to do is go with alphabetical order. So we're going to begin numbering at the left side because bromo, or B, comes before ethyl, or E, in the alphabet. So this guy gets named as a 3-bromo 5-ethyl heptane.